So let's practice some of the concepts that we've learned in week 2. So we're going to start ourselves a new file. And remember, we always start with comments with our name, some kind of date, information, and the purpose. So we're going to, in this program, practice some Python basics. So let's start out with some variables. So we could have num1, we're naming a variable, and we'll just say the num1 is 35. And we might have num2, and we can say that num2 is 20. So these are both integers, and actually we can make this one a float, and we could add these together. So we could say that our sum, call it sum1. You'll notice when this turns purple and idle, this means that this is a reserved word. We don't want to use any reserved words in naming variables. So for instance, some reserved words are the names of built-in functions like print. If turns orange, again, we don't want to use that as a variable name. Let's see, input, name of a function, we don't want to use that. In is a reserved word in Python, it turns orange. So you don't want to name any of your variables or your functions, which we'll get to in week 5. We don't want to name those anything that is reserved by the Python language as indicating something. It already has a definition, so we don't want to overwrite that definition. So if we want to use sum, which happens to be a built-in function, we're going to say sum1. It's the name of our variable, and we can say that that is equal to num1 plus num2. And now it doesn't matter if I put spaces in between the plus. I could put it all together, num1 plus num2. I can put spaces here, and in this case, the Python interpreter will interpret those correctly, whether you put the spaces in there or not. So now if I print that sum1, let's see what happens. So I'm going to run this, and again it's going to tell me the source must be saved, and so we'll just call this Python basics practice, and there we go. And it printed it out. It printed we added 35 and 20 together, we get 55.0. We added a float to an integer, it changes it into the whole thing into a float. Your sum is going to end out being a float. So what else could we do? We could, sticking with numbers, what if we decided to input a number from the user? So let's say that num3 is going to be equal to, we want to input, we're going to tell the user enter a number. So that's our prompt. It goes inside of the parentheses for input. We send this prompt to input. Input displays that in the shell for the user, and then whatever the user types in from the keyboard is going to get saved into num3. Now remember, input always returns a string. In this case, we want a number, so we could either cast this as an integer if we wanted a whole number, or a float, which will get us a whole number. I mean, it will have a decimal portion, or it will keep the decimal portion if they happen to enter a decimal portion. We would want to use an integer if for sure we needed a whole number with no fractional component, no point zero at all. We would want to use an integer, and we definitely have applications for that, as we'll see as we continue to learn how to program in Python. So when this code runs, and we'll go ahead and comment this out, so we've already played with this, so we will let it go to sleep. Okay, so let's comment this out. So interpreter is going to ignore that, and so now what's going to happen is we're going to get a number from the user and store it in num3, and then let's go ahead and print out num3 once we get it from the user. So we're going to go ahead and run this and see what happens. And here we go. Here's the prompt, enter a number. So this is what we said, give this to the user on the shell, give this to the user, and we're going to enter a number, and we'll just enter the number 30, and it's going to print us out number 30. We cast it as a float, so it's going to add on this 0.0. Let's see how it changes if I make this an integer. Enter a number, enter 20. This time it doesn't print it with the decimal point 0 component because we cast that as an integer. Now this can be a good thing or a bad thing depending on what we want. But if your user enters 20.5, the problem with this is that it's going to drop that 0.5, which may be what you want. That might be a good thing. It may, on the other hand, lose part of the value if you had intended to keep that value. So in this case, actually, you're going to get an error anyways, because the integer function requires from a string something that can actually be cast as an integer. So we actually aren't able to cast it from a string. But you know what would work? This is just kind of fun. If we cast it as a float first, we can cast it into a float, and then we'll cast that into an integer. Let me make this a little smaller and pull it up so you'll be able to see the whole window. So here we've got this. So I'm going to enter 20.5, and now it doesn't fail. So 20.5 is a string. The Python interpreter can't turn this into an integer. It doesn't know enough to make this a float and then make it an integer. It's just going to fail. This isn't an integer equivalent. This would be just 20 by itself, but it gets thrown off by this decimal point. However, the float function can handle that, so it turns it into a float. We'll turn this into 20.5, and then it will drop this portion when you cast as an integer. So we avoided this error, and what we ended out with, though, we dropped the fractional portion of that integer. So play around with this. We can do something like, you can even just, let's get rid of the input function. If you had just done 20.5 and turn this into a float, we'll see how this works. It works. So this is essentially what we did. We took the string, we turned it into an appropriate float, and we could cast that as an integer. So there's some examples of casting. Let's play around a little bit more with some numbers with some of the other operations that we have. So let's go ahead and just comment this out. So we know in Python that we can add, subtract, multiply, divide. We've got floor division, we have modulo, and we have exponent for ways that we can perform calculations with numbers. So for instance, let's say I've got num4 is equal to 100, and I have num5 is equal to 5. I could say that my total is equal to num4 times num5. And if I print my total, I'll be able to see what we should get is 100 times 5 should be 500. So if we run this, we will see we get 500. What if we change this to division? So now we are dividing 100 by 5. We should get 20. There we go. What if we take 100 to the 5th power? We get this really big number. Let's see, what else do we have? We could add these together. Oh, we could subtract these. So we could subtract these, run this, and we're going to get 95. Let's change these numbers a bit. So what if I did this as 101? Let's check out what we get with division. This will be fun. Here we get 20.2. So Python is smart enough that even though we took an integer and we divided it by an integer, it still returned us the fractional component. You should know that in other languages, this doesn't happen. If you divide an integer by an integer, what you'll get is an integer. It will drop this remainder portion, this fractional portion, just like floor division does in Python. So if we run this, it's going to perform the division 101 divided by 5, but it's going to drop the remainder. So what you're going to get is 20. So this part just disappeared. It performs the division operation, just drop what's left. Whereas modulo is kind of the reverse of that. It's going to drop how many times it goes in and just give you the remainder. So in this case, 5 goes into 101 20 times and there's 1 left over. So what you get with 101 mod 5 is 1. And you don't have to use these variable names. You could hard code and put in the 101 and the 5. Python lets you do that. I can actually just say here total is equal to 101 mod 5. We try to avoid hard coding though, because it's not as useful as if we make a general solution that then we can just change the values of the variables and get a new equation basically. So this is a lot less desirable than using variable names, because this is going to make our programs more flexible and easier to reuse. So we don't have to limit ourselves to one operation. Comment that out. We can do a whole string of operations, but we have to keep in mind that order of operations or operator precedence. We have to be able to follow those rules to get the right logical answer. So we have some sort of equation, total is equal to, and we can go ahead, let's use these variables right here. So we'll uncomment these so we can use them. So we have num4 and num5 and let's say a num6, and this is going to equal 50. So let's say we have something like num4 minus 1 plus num5 divided by num6. So if we keep this equation just like this, orders of operation says this is going to happen first. So num5 divided by num6 is going to get us, let's see, 5 divided by 50, it's going to go in there 0.1 times. So we're going to take 100 minus 101, minus 1, sorry, we're going to get 100 and we're going to add 0.1. So if we run this, we should get 100.1, which is what we get, because the division is going to happen first and then we're going to start over here and go from left to right. What if instead we put some parentheses around this part? So this means all of this will happen before it's divided by num6. So we're actually going to do this first. We start with the parentheses, 101 minus 1, which is going to get us 100, plus num5, so that's going to get us 105, and then we're going to divide 105 by 50. So that's going to be a 2 and some change. So here we go, 2.1. So how we structure these, how we put the parentheses, if we had, something else going on here where then we had by 50, then this is all going to happen, and then we're going to multiply the whole thing by 50. If we removed these parentheses, we would get a very different number. So play around with these, play around with all of these. Make sure you understand how modulo works, make sure you understand how floor division works, and make sure you understand how using parentheses and moving things around, how the orders of operations helps you to get the answer that you're looking for when we're calculating. All right. So the next thing that we want to practice is we want to practice a little bit with strings. So that's our numbers, our floats and our integers. With strings, there are some different things we can do with strings. So let's say we have something like name is equal to Joe, and maybe this will be first name is equal to Joe, and then maybe we have last name is equal to Lee. Then we have something like age is equal to 25, or perhaps birth year is equal to 1980. So we're collecting pieces of data, and we can actually think about this in the same way. We had an earlier lecture where we talked about abstraction. So abstraction is really important in computer science. We have to be able to represent the physical world in our computer programs. We have to represent physical things as data. So this might be a student. Let's say we're creating an application that keeps track of information about students, and maybe this is just we're just keeping personal information about every student. So we might need the student's first name will be a string, student's last name will be a string, the age maybe a number, could be a string depending on what we want to do with it. I mean, we probably will be updating it, but it's not likely we're going to need to add the age to anything. Possibly. On the other hand, if we needed to use the age to figure out whether or not someone could drink, then we might have to compare it to 21, and in order to make that comparison, it would have to be a number. So how you represent that data, the data type that you choose, really depends on what you plan to do with that data. Birth date, birth year may want to be a number because we may want to use that to calculate age, and then we wouldn't even have to store age. We would just have to store the birth year. We would be able to retrieve today's date from the system, be able to do a calculation and be able to get the person's age without having that extra piece of data to store. So we can do lots of things with strings. Right now, we may just be interested in getting some data from the users and printing it out. There is one cool thing that we can do with strings. We can actually add them together. It doesn't really perform any calculation. It literally just sticks them together. We call this concatenation. But let's say I wanted to print this student's name, then I could say print first name plus a space between them plus last name, and when this prints, it'll have Joe with a space and then Lee printed out pretty nicely for us. So if I run this, we can take a look and we can see that Joe Lee is printed out. So concatenation is really helpful. In order to use concatenation, everything that you're concatenating together has to be a string. So first name is a string, the space is a string, and last name is a string. If, for instance, I were to try to then concatenate the birth year, this won't work. So I'll run this, and we're going to get an error. It says we can only concatenate strings, not integers. So we're not able to concatenate an integer with strings unless we put the casting function. We can go ahead and use the casting function to cast. Let me move this over so you can see it a little better. To cast birth year as a string. And again, we may want to go ahead and add in a space so that these look nice, and you'll notice that you have to put the plus in between each string. So there's a plus here, there's a plus here, there's a plus here, there's a plus here. If you don't have that plus, we'll also get an error. So you may see this. These are all syntax errors here. It's actually just going to tell us right here we have a syntax problem. We need to put in the concatenation. But once we have this all concatenated together, then it's going to print Joe Lee 1980 separated by spaces because birth year is now a string. If we don't want to use the concatenation function, we can use in Python commas to separate string data and non-string data. So we have print, and we might say the string birth year, and then we can say birth year. So this is going to print the literal string birth year colon space, and it's going to print what's stored in the variable birth year. The thing with this comma is that it always adds a space for us, so we don't need this part right here to actually add in a space. So I can actually get rid of that space there, and it will still put a space in there for us. This can cause a problem if you don't want that extra space, in which case you would have to use concatenation and cast every non-string string data piece into a string in order to concatenate those together. But let's comment this out and let's go ahead and print this to the screen. So here we see birth year, we see 1980, and I don't have a space here, but this comma actually added a space in for me. This here is a string, birth year is an integer, and this comma lets me print them both together on the same line. So this week we're practicing variables, we're practicing understanding data types, we're inputting data from the user. Remember, input always gives us a string. If we want it to be a number to be able to use in numerical operations, we have to cast it as an integer or as a float. You may see the eval function also looks something like this, casting function. This takes your piece of data and turns it either into an integer or a float depending on what you send it. So play around with this one and see what you get with the eval function. You're also going to want to practice the print function, practice concatenating strings together, practice using a comma to print different data types onto the same line. You will also want to practice the end parameter with the print function. So print always prints everything onto one line if you want, and then goes to the next line. So by default, this end character is the escape n, and this mean goes to the next line. So this is what's normally the default. This is always the case whenever you use the print function unless you change this. If I were to turn this, say, into a space instead, and move this up here, let's get rid of that, you'll see what's going to happen. Well, first let's do it without this. Hold on. Okay, if I print both of these together, you're going to get birth year 1980. That's this first line that the interpreter processes. The second line the interpreter processes is this print statement, and we're going to get birth year 1980 and then Jolie 1980. But let's see what happens if I were to make this change. Let's turn that n parameter into just a space. Now, instead of going to the next line, which is that escape n character, that means go to the next line, always the default, but I've overwritten that now with this space. So now instead of going to the next line, it just puts in a space and then prints the next line right next to it. So these are some things that you're going to want to practice and master. So let me know if there's anything else in this week's reading that you'd like me to make a video on demonstrating. So all right, good luck. Oh, and have fun. Yay, programming.